You see, whenever I look at a problem in physics, I always ask the same question. What is the arrow pointing to? Not the arrow on a map, I mean the arrow of time, the arrow of change. Nature has a funny rule, a rule we don't like very much. It says you can scramble an egg, but you cannot unscramble it. You can turn a glass of wine into a spill on the rug, but you cannot turn the spill back into a glass of wine. There's a direction to things, a flow, and if you try to swim against that flow, you have to pay a price. Usually the price is energy. The price is order turning into disorder. Now people ask me, Richard, what do you think about going to Mars? And they show me these beautiful pictures of rockets and domes and people growing potatoes in red soil. It looks wonderful. It looks like an adventure, the next chapter in the great human story. We went to the moon, so naturally we must go to Mars. It's just the next stepping stone, right? But I have to stop them. I have to say, wait a minute, you're thinking like a geographer, looking at distance as if it's just miles. But in physics, distance isn't just space. Distance is a relationship between forces. And when you look at the forces involved in going to Mars, and more importantly, the forces involved in coming back, you realize something terrifying. It's not a stepping stone, it's a trap. Not in a sci-fi way. I don't mean monsters there. I mean the laws of physics, specifically thermodynamics and biology, have conspired to make it a one-way trip. Not because the rocket breaks, but because the passenger breaks. Because you break. Let's start with the first trap, waiting for you right on the surface. The dust. You might say, Richard, it's just dirt. We have dirt on Earth. Sandstorms in the Sahara. We deal with it. Brooms, vacuum cleaners, what's the big deal? Well, let me tell you about the history of a grain of sand on Earth. It's violent, but also smoothing. On Earth, we have water, rain, oceans. For billions of years, every grain of sand has been tumbled around, washed, rolled back and forth by waves. Take a jagged piece of glass and put it in a rock tumbler for 1,000 years. What comes out? A smooth marble, round, soft. If you rub it between your fingers, it feels like powder. That's Earth dust, friendly dust. But Mars is a dead world. It's been dead for a very long time. No rain, no rivers, no oceans. The only thing that happens to rocks on Mars is that they get hit, smashed by meteorites, big and small, for 4 billion years. So when you look at a grain of Martian dust under a microscope, you don't see a marble. You see a shard, a knife, jagged, with edges so sharp they're almost 1 molecule thick. It's not dust, it's microscopic broken glass. And it gets worse because Mars is so dry. No humidity to conduct electricity away. So these little shards of glass pick up an electrostatic charge. They become like little magnets. Now imagine this. You land your ship. You need to make fuel to go home. You can't bring the fuel with you because fuel is heavy. If you tried to bring the return fuel, you'd need a rocket the size of the Empire State Building just to launch it. So you have to make it there. Engineers call this in situ resource utilization, a fancy name for digging up stuff and burning it. You need to mine ice from the ground, suck carbon dioxide from the air, run pumps and compressors, have seals that rotate, bearings that spin. But here comes the dust, magnetic, broken glass. It doesn't just sit on the ground. Electric fields lift it up. It floats in the air and sticks to everything. Your solar panels, your suit, and most importantly, your machines. It gets into bearings, and because it's harder than steel and sharper than a razor, it grinds the bearings down. It eats metal. It gets into rubber seals and cuts them to ribbons. You try to wipe it off, but you can't because it's magnetic. You just grind it in deeper. So there you are, the greatest engineer in history, having built a magnificent factory on Mars to make rocket fuel. But the factory is destroying itself. Gears seize up, valves leak, solar panels get covered in brown soot you can't wash off because there's no water. Physics fights you, electrostatic forces, friction. And you realize the machine you built to get you home is dead. But let's be optimistic. I like to be optimistic. Suppose you solve the dust problem. Invent some magical material the dust can't cut. You make your fuel, fill the tank, you're ready to go. Now we come to the second trap. This one isn't about the machine, it's about the meat. It's about you. We have to talk about radiation. People hear that word and think of glowing green slime or nuclear bombs. But radiation is simpler and scarier than that. Radiation is just little bullets, tiny particles, protons, helium nuclei moving nearly the speed of light. On Earth, we're spoiled. Incredibly lucky. We have two shields, the magnetic field, which catches these bullets and spirals them away to the poles, making the northern lights, and the atmosphere, a thick blanket of air. By the time a cosmic ray reaches you on Earth's surface, it has hit so many air molecules that it's tired, weak, harmless. But between Earth and Mars, there's nothing, a shooting gallery. The sun shoots protons at you. The rest of the galaxy shoots heavy ions. On a 6-month trip there and 6 months back, You're standing in the middle of a firing squad. What happens when one of these bullets hits you? You're made of atoms, hydrogen, carbon, oxygen, glued together by electrons. Those electrons hold your molecules and your DNA together. When a high-energy cosmic ray screams through your ship, it ignores the hull, goes right through your skin, and crashes into your atoms. It knocks electrons flying like throwing a bowling ball into a house of cards. The structure collapses. The chemical bond breaks. This is called ionization. Your body is a miracle machine with repair crews, tiny proteins that run around looking for damage. They see a broken piece of DNA and tape it back together. Usually they do a good job, but on the trip to Mars, damage happens too fast. It's like trying to fix a roof during a hurricane. The repair crews make mistakes. They tape the wrong pieces together, connecting a gene that tells the cell to grow with a gene that tells it to stop. The cell gets confused. It forgets what it is, thinks it's supposed to just grow and grow. That's cancer. But cancer takes years. You might say, Richard, I can take the risk of getting cancer in 20 years if it means I walk on Mars today. But there's something faster, something that happens before cancer, damage to your brain and kidneys. Nerve cells don't replace themselves well. When a high-energy heavy ion hits a neuron in your brain, it leaves a track of dead tissue, a microscopic bullet wound. Over a long trip, your brain is literally being Swiss cheesed. You lose cognitive function, you forget things, you get confused. Imagine trying to land a spaceship when you can't remember which button does what because the part of your brain that stored that memory has been destroyed by a particle from a supernova 1,000 light years away. And the kidneys, the filters of your blood, delicate structures made of miles of tiny tubes. Radiation hates these tubes. It scars them, makes them stiff. So here's the scenario. You survive the dust, make your fuel, get halfway home. But your kidneys are failing. Your blood is full of toxins because the filters are broken. You need dialysis, a machine to clean your blood, but you don't have a hospital. You're in a tin can millions of miles from the nearest doctor. You die not because the ship failed, but because the physics of the universe tore your biological machinery apart at the atomic level. But wait, it gets worse. There's a third trap, and this one really keeps me up at night because it's so subtle, so elegant. The trap of gravity. Gravity is a mystery. Newton gave us the math but didn't know what it was. Einstein said it's not a pull, space itself is curved. But however you picture it, gravity is the force that shaped you. Every muscle, every bone, every valve in your veins is designed for one thing: to fight Earth's gravity, to fight 1G. Your heart is a fist-sized pump that has to squeeze hard enough to shoot blood up against gravity to your brain. It works hard, beat after beat, day after day, like a weightlifter holding a barbell. Now you go to Mars. Mars is small, with weak gravity, only 38% of Earth's. Suddenly your heart says, hey, why was I working so hard? This is easy, I can relax. And biology, being very efficient, throws away what it doesn't need. It says, we're wasting energy on this big heart muscle, let's shrink it. So your heart gets smaller, weaker. It literally changes shape. And your bones, oh, the bones are the worst. You think your skeleton is like a steel frame inside a building, but it's not. It's a bank for calcium. On Earth, you constantly make deposits and withdrawals. Your body puts calcium in to make bones strong against gravity. But on Mars, your body says, we don't need this heavy frame anymore, we're floating around, let's make a withdrawal. So the cells that eat bone work overtime, dissolving your skeleton and dumping calcium into your blood. Your bones become porous, like a honeycomb, like chalk. That's fine as long as you stay on Mars. You become a Martian, adapted to low gravity. But remember the title, No Way Back Home. Imagine you try to come back. You get in your ship, float for 6 months, your bones get even weaker, your heart even smaller. Then you hit Earth's atmosphere, pulling G's, the deceleration crushing. But let's say you survive that. The capsule splashes down, the hatch opens. You see blue sky, smell salt air. You try to stand up and you collapse. Because suddenly you're back in 1G, but you're trying to fight it with a 38% G body. Your shriveled heart tries to pump blood to your head, but can't. Earth gravity pulls the blood down into your legs. Your brain starves for oxygen. You faint. Your bones, now made of chalk, try to support your weight. They snap. Multiple fractures just from trying to stand up. You're being crushed not by a rock or a monster, but by your own home. By the very environment you were born in. Because you're not you anymore. You've changed. Mars has re-engineered you, twisted your biology to fit itself. And this brings me to the deepest point. We talk about isolated systems in physics, but in reality, nothing is isolated. You are not separate from the Earth. You think you're an individual walking around on top of a planet, but you're not. You are part of the planet. an extrusion of it, made of Earth materials, tuned to Earth's gravity, shielded by Earth's magnetic field. When you leave that system, you're like a fish jumping out of water. A fish can jump out for a few seconds, see the air and the sun, but it can't live there. If it stays, it dies. We think that because we have technology, rockets, computers, we can cheat this rule. Build a fish tank and carry it with us. But the tank is leaky. Radiation gets in, gravity gets out, dust gets in. The universe is always trying to bring you into equilibrium with your surroundings. On Mars, equilibrium means death, or at the very least becoming something that can never leave Mars. So when I see those plans for colonization, timelines saying we'll have 1 million people on Mars by 2050, I have to laugh. A sad laugh, because they're ignoring the fundamental laws of nature. They're treating biology like software you can just patch. But biology is hardware, and it took 4 billion years to develop for exactly one environment, this one. Does that mean we shouldn't go? No. I'm an explorer. I believe in curiosity. We should send our eyes and ears, send robots. Robots are wonderful. They don't get cancer. Their bones don't dissolve. They can sleep in the dust for 1,000 years and wake up and say hello. But for us, these sacks of water and protein called human beings, we need to be humble. We need to realize we are not the masters of the universe. We are the children of Earth. Like all children, we can wander a little, play in the backyard. But at the end of the day, we have to come home. If we go too far, cross that dark ocean to that red dot, we might find the door has locked behind us. We might find we'd become aliens on our own home world. So look at that pale blue dot. That's where you belong. That's where the air is sweet, the gravity just right, and the magnetic field wraps around you like a warm blanket. Don't take it for granted. It's the only house you'll ever have.